This first video is going to cover the one sample test for population mean. You're going to use this when you have one sample that has numeric data. So in this case, in the example question, I'm looking at the average family size. So that's numeric and it's only one sample. The question that I want to answer has to do with the average family size in the US, which is 3.14. I want to know if the average family size of my class is greater than 3.14. So before we even carry out the test, we need to check the assumptions. This goes along with the packet that you were given in class and that's posted on Schoology. There are two assumptions. The first assumption has to be checked for every test, every interval, and that's that you have a random sample. So in other words, you randomly chose times to collect data, you didn't skew your data one way or another. As long as you have a solid study design, that assumption should be met. The one that we're more concerned about is this large sample. So either our sample has to be large or it has to not show skewness or outliers. The data set that I gave you in class has 29 observations. So it's not large, it's close, but it's not exactly large. So what I need to check instead is make sure that it doesn't show skewness or outliers. So I'm going to look at a graph. I'm really only interested in the number of people in a family. So this is a dot plot that I got. It looks fairly symmetric. This could be an outlier because it's pretty far away. Because our sample size is pretty close to 30 and we only have one outlier, we're going to say that that assumption is met. If you have a small sample size, like 10 or 15, something pretty far below 30, and your sample is really skewed, then you're either going to need to come talk to me, Miss Budden, or talk to your mentor about a different test to use. So now that that assumption is met, we're actually going to carry out the test. So you're going to drag the test icon. In the upper right, you need to choose the test you're doing. So we're doing a test for mean. It's going to ask you what variable you want to look at. We're looking at the family size. Anything in blue is something that you can change. So I want to test whether the average family size, or what I called people, is greater than 3.14. When I change that, at the very bottom I get a p-value. My p-value is something less than 0.0001. Remember that for a p-value, you're going to compare it to 0.05. Because this p-value is less than 0.05, we are going to reject the null, which means that we do have evidence that the average family size of the students in my class is greater than 3.14. It does not mean that it definitively is, it just means that we have evidence that yes, the average family size is greater than 3.14. Generally, a hypothesis test is then followed by a confidence interval, so that's under estimate. Again, you're going to need to choose the estimate you want. We want an estimate for mean. Again, you're going to drag that statistic you're looking at. 95% is generally the rule of thumb for a confidence interval. If your mentor tells you to change that, you can. We like to keep it around 95% though. This is the confidence interval. So this tells us that we believe the average family size of my students is somewhere between 4 and 5.18 people. This confirms what we got in our hypothesis test because 3.14 is not in the interval. The entire interval is greater than 3.14, which is why we have evidence that the average family size is bigger than 3.14.